Test, test. Oh, okay. There we go. That works. And music playing at approximately appropriate volume. That's not going to get my stream stopped. Okay. Cool. And then volume down so I can hear things. And it's still well below my voice, which is good. All right. So, I haven't streamed in a while. My bad. Whoops. I moved. That's why there's a whole bunch of stuff behind me in like a not very ordered pile. Yeah, I don't think I really need to give much more context than that. Life's been a mess, as life is. But I was recently, a guy I know through a Discord channel reached out to me with some questions about a model that he had that he was having trouble making that had some kind of complicated sheet metal features that, like, if you look at it and you don't know how to deal with both sheet metal and surfacing tools, you're going to be kind of stuck in a rut. Even if you've got, like, the more sort of brute force tools like Combine and specifically the subtract features in Combine for making aspects of this. I don't really have a great picture. There's one on the thumbnail, of course, but the feature in particular that presents issues is this little guy right here. That's actually plate construction. That's not sheet metal. Interesting. It's a sandblasting card of some kind. I assume he either works for them or is doing this as a student project. And I'm like, whatever. Yeah, it'd be an interesting thing to solve. Lots of dimensions here. Lots of stuff that's not really all that pertinent to me. I probably will not bother modeling all of this, and I think it's more interesting to tackle this as a sheet metal problem, as a bent sheet metal problem, rather than a welded construction, which is what this appears to be. I mean, now that I have this drawing, because I didn't look all the way through this very thoroughly, it looks like this is just lots of individual plates welded together, so makes sense if you don't have a way to form things, or you don't have a bender. In particular, this would not be, like, you wouldn't want to leave that there. You'd want this to be just a section that, say, leaves some space and comes out to form that U shape. You could even cut it out of a section of U channel if you had one of those magic extruding, like, CNC laser cutters that will cut sections. Those things are fantastic. Great for ultra high production, like, precise laser cut section parts, but probably overkill here because my guess is this is being made in Turkey, because all of the notes and descriptions of things are in Turkish, which I cannot read, so we're flying a little bit by the seat of our pants. But fortunately, numbers, not just limited to Turkish, still using the Roman numeral system, not Roman numeral system. I don't know what kind of numeral system this is. Arabic numerals. Brain fart. So we'll just stick to this and probably work from this guy as a start to get our vessel, and then put together... Hang on. Okay, I've got to have better music than this. What have I got for playlists? Bum, 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 bum. I mean, I really like that album. It's just too much. Let's do Zep's Station Kara is always good. If the guy who set up Zep's Station Kara makes money off this, congrats, dude. I'm happy. Glad that I'm making you some cash. Some interesting things about looking through this drawing. Let's see. It says it's 5mm thickness everywhere. That looks like a different thickness to me. That's fine. I'm sure it's not really a big deal. This is just a sort of a one-off drawing. No dimension on that radius there, also fine, because I don't think I could shape that in sheet metal, because that's a doubly curved surface, and it's just not something I want to deal with, so it will make it a pretty simple shape. But I'll try and match everything else, I think. Maybe not that internal dome dish shape, just because it doesn't really matter for the sheet metal I care about. Yeah, alright, so we got 700, 746, 223. Let's hop right into it. Oh, one more thing. I want to know where to start that relative to the origin so that it's in a nice spot off the ground. Let's see. Wow, these ones over here are really small. 1192, we'll just go ahead and make that 1200 and call it even. Or I could just start with the bottom as the origin. I'll just start with the bottom as the origin. That's easier. Okay. And whoops, that doesn't hide all the way. Please go away. Thank you. New part. Milligrams, not milligrams, millimeters. SolidWorks being fussy. Alright, revolved base. Just nice and easy because this part is going to be a big round shape. I could probably do this as a thin section too and save myself some thinking. So this one was 746. 223. Some poor decisions made there with my choice of coloration for selected items, but I need to fix that. I just haven't gotten around to it. Let's say this is maybe 30 for right now. And then give myself a center axis. This means that when I finish the command, it'll just straight up assume, oh hey, that's where you want things. It'll be right. So let's make that 700. And then, can I, oh, it's not letting me, there we go. Okay, Alt-tabbing will work a little better now. 5 millimeters, and it doesn't give me a diameter at the center of that guy, which is a little frustrating. Is there anything else in this drawing? I was hopeful that there was going to be... In fact, I thought I saw something about the diameter of that nozzle. But I could very well have been hallucinating. Oh, here we go. Yeah. 76. So, that's kind of funny. That's about 3 inches. In fact, I can't think of a reason for that to be 76 other than because it's supposed to be semi-imperial, but that doesn't really make sense, so I'm just going to make it 75. This guy is complaining about position. That needs to be horizontal there. And all locked in. Sketch is currently open. I do not want it to be closed. I would like it to be open. And then we'll switch to the front view here just to make sure that we're on the right side of our thin extrude, or thin revolve rather. Call it all good. There we go. There's our vessel. I think I want that to be maybe a little bit bigger, actually. 76 across on the mouth. It just feels too small, doesn't it? Like if this is supposed to be 200, it looks more like 100 maybe. So I have a way to measure. Length, yeah, okay, that is 100. So I'll just make that 100 then. That looks a little more right. Doesn't really matter that much. Kind of nice to be right anyway. Save that out. Move that off to the side so I can call this sandblasting part. Oh, I just realized. Hang on. No, you can get out of there. No more DXE. I forgot to turn on my keyboard viewer. And now I need to remember to not type passwords. Okay, so now we've got our cart. We've got it in roughly a reasonable position. Seems about right. The first thing I'm going to do is, because I have parts terminating on this, yeah, I know I can't move it to itself. I'm going to do an offset surface and say 0. That leaves the solid up here, but it gives me another body that I can work with and I can use to trim things later. So we'll come back here to the front plane and say start a base flange, sheet metal. Say I make this... Actually, I have dimensions now, so I can go and figure out what that's supposed to be. Assuming that's covered in the dimensions, which it might not be. Let's see, I would expect it to be... Here we go. Outboard, it's 136. Doesn't have height overall, that's fine. But we can see it ends somewhere, maybe a third down the lip. See if I can't find a better dimension somewhere. Oh, those actually might be our only dimensions. Maybe that's all I get. Yep, looks like those are all the dimensions I get. Okay, So I'll just wing it from here on out. What's more important is the technique than the exact dimensions. So to align this on a center, I'm going to add a vertical line there, so it's really easy for whoever comes after me to look at that and say, oh yeah, that's probably what he wanted to do here. Make that 200 millimeters just as a guess. Make this 36. That seemed a little skinny. I'll just make it 150. Give myself a height from the origin. Say also 150. How does that look? Looks fine. And now we can go sheet metal, base flange. And it's starting with what looks like rounded imperial numbers, so I'm going to say 5 mil thick sheet metal. And do the same for first direction, set a 5 millimeter on the interior radius. That'll be a nice, a pretty nice factor. So direction 1, we want to do, what does 2 meters look like? Way too much. Okay. What's half a meter look like? That looks about right. So we'll call that good. And then, oh goodness. May have goofed here. Huh. Let's try, I think it's a trim that I use. Okay, intersect, that's what I'm thinking of. Nope, can't use a sheet metal body. What did I use? Modeling. Combine. Maybe I used a thicken? This was way easier the last time I did this. I don't remember. Okay, sheet metal. There's got to be a way to... How did I show him how to do this? Hang on. I think I gotta go find the Slack that I did this in originally. I'm quite surprised, because I remember this being like, oh yeah, I can just do this, 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 and it would just work last time. But I think I may not have been working directly with sheet metal last time. Maybe I used an intermediate. Ah, I did convert it. Okay. So we'll delete this base flange, and the sheet metal folder. And probably the sketch too. Well, and we'll keep it. Okay, so extruded solid, thin feature one direction, make sure it's on the right side, blind, half a meter, seems about right. And is it gonna, when it says autofill at corners, is that gonna do, it does, nice. Okay, now we can use an intersect. And intersect, consume surfaces. Actually, maybe I don't want to consume surfaces. Maybe I need this later. Yeah, don't consume that surface. Convert to sheet metal, or here's what we'll do. We'll come from the side and trim some stuff out of the bottom too, just so that it's a little more accurate to what the finished part was. I think maybe I even want to extend that a little, so let's make this 600 or 550. Part, features, extruded cut, right plane. I'm going to start from the center line and come over and say probably, let's make this 150 just so it's nice and square. Add this as a, no, come on, get over there. Radius 10 seems about right. And then for safety, I am going to add a split line here and then use this as a single continuous, so it's a closed section. So it's a little safer cut rather than removing potentially unwanted parts of the body. And I just realized I made that blind, which will have the nice fun effect of doing not much. If we do through all both, it'll cut what I want. There we go. Selected body's all accurate. Now, convert to sheet metal. Sheet metal parameters start there. Radius 5, thickness 5, bend edges. Oop. Looks good to me. Ah, interesting. Okay, so by selecting the outside there, it made the part thicker into the way, and that's not really what I want. If I start from here and then collect all bends, I wonder if it'll... It did! Yeah, cool. So now, we can see that it'll touch, but it won't intersect inwards. What I did there was basically just change the side that I wanted the sheet metal to call its, I guess, root face, really? So that it's using this interior face as the definition for the flat part. And now we can even go and say sheet metal, where's the flat pattern? Flat, there we go. And there's a flat pattern part that you could use. I'll probably add some nice big chamfers. I'm curious what the purpose of the... Hang on, there was a... break corner, there we go. Interesting that this is just sort of a... Yeah, we'll not let you do specific chamfers, but I guess that's fine. Fine by me. I think I'll also bring this down a little, maybe 130 is a little better. Or even 120? Or 100. Yeah, that looks better. I would want more support underneath here, just if I was just doing it my way. Feels like it would, you know, give you a little more security. The other thing to note, because we're dealing with a slice of a conic section, because of the way this shape comes out, this is not a straight line. That's an arc. And on top of that, because of where it is, I think it's a hyperbola. I'm not going to bother going through like trying to calculate it and find the exact equation, but slices through cones that are on planes parallel to the axis between the cones will create a hyperbola. I think if you're... I don't remember... If it's parallel to the angle of the cone, then it's a parabola. If it's perpendicular to the plane of the cone, it's a circle. If it's none of the rest of those, it's an ellipse, I think. No, someone's gonna double check me on that, whatever. Okay, so let's hide that, show this. There's your two solid parts, including a base for, you know, where to put a wheel. I bet if we go and pull up McMaster and say, caster wheel, say metric, we have a whole pattern maybe? Mount height. Surely some of these are just big square guys. That's kind of what I'm looking for. Huh, I guess not. I got some really fancy ones, but that's not really what we're looking for. But you could use any of these and just, you know, say put a thread hole here with a flat pattern, and you'd get something good enough. If you wanted to be clever, you could probably drill it out oversized and then use maybe a nut welded onto the backside if you were like manufacturing this on your own. In a production environment, you'd probably want just a, or even better, a form tapped hole through the part would be the right way to go. That would give you something both nice and stiff and without causing... It would be efficient, I think, and cost-effective from a manufacturing perspective. Now the trickier part is coming back here and coming up with something that meets up with that. So we'll hide, or show the surface part again and hide the non-sheet metal part. So on the drawing, we have Looks like these are pretty much radial. Maybe even on center line, which is nice. Looks like they... In some views, it shows that they come down to meet an axle in the middle. Oh, what if that's... What if what we're seeing in the middle there is an axle through? I can totally see that being an axle. It's probably cheaper that way to do it than what I'm thinking of with like a... Yeah, here we go. It's a 20 mil shaft. 740 on the outside of this, and then radial inward from there. And it doesn't really give a... Oh hey, we even get a wheelbase. Never mind. Okay, maybe I'll try and be correct about this a little bit. So we'll start from the underside and say sketch. Do we want to do this as multiple piece parts? I think so. Or I don't know. I think no matter my exact accuracy, I'm going to end up with a part that would be pretty close to hitting the center line. Like, even if they cut slightly on the wrong side of, like, one way or the other, the part will fit up pretty well, and because it's a three-wheeled cart, it's not really going to have too many issues. To that end, I think I kind of want to do this. I want to make this as a single sheet metal part, just because it'd be fun. So we're going to do... start from the front plane, sketch, and we'll say, let's see, need to come up here, over, down, go from the center line there, up, vertical. Is someone sending messages? No, okay, we're good. How far? Let's say that this needs to be 150 millimeters. It's probably fine. Oh, but we do know the exterior diameter, or the exterior size of this, which is 740, which is pretty big, actually, now that I think about it. Like, I think that ends up being wider than the tub itself. We'll give this some height. Oh, I don't know. 100 seems fine. Maybe a little taller. Nah, screw it. Close enough. Thinking too much about this already. We'll do an extruded base, same as before. Thin extrude with auto fillets, just because it makes things nice. And we'll start with an offset. Come back maybe 300 millimeters in the other direction. Make it 300 millimeters long. Whoops, flip direction. Yeah, that looks pretty good. I think I might try and... How do I want to do this? I'll make it a little longer. That's only a foot long. Let's do 450 millimeters long, and that gives you a nice big flat platform to rest your feet on or something. Tilt the thing upward. I think maybe I'll try and be a little clever and move it in, and then do a cutout in here. That'd be more fun. So, extruded cut, top plane, and for added detail, let's do a top plane slice to just above the surface there. And then say I want some clearance to it, make this maybe 300 millimeters is probably fine. Or, whoops. How big was it before? Let's do 600. Extruded cut. Through all, flip direction, and I only want this guy. So now we have a nice big cutout to clear everything. And now, because we're working on just a regular solid, I can be kind of clever and stick to just clever is probably not the right word. I have to be a little more careful about how I do my thin extrudes now, because I'm working with just... I don't have any of the kindness of sheet metal tools, so I'll start with something coming off the origin here. Go directly to that. Make this guy tangent. And, whoops, come on, let me add a dimension, please. Thank you. 5mm, looks good to me. And then we'll do extruded, nope, not extruded cut, sorry. Extruded boss. Extruded up. 450's probably fine. Yeah, and we'll skip merging too, actually, so that I can do, I can be a little more strategic in how I place my cuts. And then I'll do an extruded cut on this plane, specifically because that lets me be a little more careful about where I'm completing the, where I'm making flat points. So, we can pick this guy and say, or better yet, we can pick this. Oh, is it not going to let me put that on the surface? Oh, that's quite rude. Come on now. Well, there's workarounds for that, fortunately. We can add 2 construction lines. Make all of these collinear. Pick that, that sort of round point where I want my endpoint to be. Pick it down here. Give myself an endpoint. And, oop, that's a little silly. Come on now. Pierce it in 2 places, and now I have a defined cut that will always end on, that will always end where I want it. Pick that guy and there, say merge. Terminate this, call it linear, seems fine by me. I almost wonder if I don't want a little more fun angle to this. Well, that's interesting. That lines up right there, or very nearly. We'll say that this has some length of 300 actually be really nice. That almost looks like I did that on purpose. I promise I didn't. So we'll do flip-sided cut. Don't auto-select bodies, just do this one. And it should, yeah, give us something that's not too unreasonable for a body there. So we'll mirror this guy over, mirror face on right plane, features to mirror. Well, rather than doing features, let's do bodies. For reasons that, I don't know, I don't think there's a good reason to go one way or the other right now, so. But when we combine all those up, and we say, please give me, hang on, if I do a normal plane here, I want, okay, I want the outside face to be, or do I? Hang on. Is it, oh no, it's the inside face that's on the origin. So if I show the origin here for a sec, it's on the inside face. So I want this guy to be the main one for my conversion. So we'll do convert to sheet metal, pick this guy, collect all bends, say okay. There we go. Now we got a sheet metal part. We can do sheet metal things with it. This includes nice magic stuff such as tab and slot. Freaking love tab and slot. Absolutely saved my ass working on a really big project once. Just really a phenomenal tool. Very specific use cases, but when you do get the chance to use it, it's magic. Let's see, how do I want to do this? I think I might want to add like a reinforcement in there if I was doing this for real, but I'll skip out of that since it's not particularly important. But yeah, really the magic here is trimming things and intersecting and using intersect to cut your bodies before. In fact, we can go back and do that with the combine. We can say intersect, and I imagine we'll probably have some regions to get rid of up here. So if we get rid of this guy, and say consume surfaces, because this is the last intersect we're going to do. If we convert solid, now we have straight 90 degrees, straight 90 degrees, and they're all sheet metal parts. So, well, excepting the obvious one because that'd be really difficult to do in sheet metal, and I'm lazy. So, Yeah. I don't think I really have any other clever question or any other clever things to answer here. Just, careful use of the intersect tool. If you have a complicated sheet metal part, potentially starting with a thin extrude is a great way to reduce the complexity and silliness that you have to have with, like trying to manage and bring things up to edges, because that won't let you use more complicated tools that give you a little more control, like intersect. So, something to be said for that. I think I want to do one more. Let's do one more clever bit. Let's do sketch on the right plane. Just because this is something I did on the other one, and I think it's interesting to do here. We'll leave that floating, or actually no. Here's what we'll do. We'll fix it in place just so it's not moving around that much. Does that let me? Oh, it does let me move that. Okay. Let's give that some extension then. And come out here and say features, sheet metal, base flange, up to surface. Ooh. Up to surface. There we go. Okay. Here's something where you can use intersect to trim stuff off. Could be wrong. Let's do for offset. Boop, boop. Boop. Create 2 new surfaces. Hide the main body. Intersect. Ah, I can't. It's quite rude. So in that case, I'll do this instead of as a base flange. Extruded boss, because this doesn't really need to be sheet metal yet. I'm working with all flat features. As long as I'm careful about where I'm finishing things off, when I convert it to sheet metal at the end, will come out fine. So we'll just do a thin one direction. Ooh, hang on. I might even be able to get cleverer with this. Before the surface offset, can I do extruded boss up to body on this guy, direction 2, up to body on this guy, do not merge result. Oh, solid surface body, that's rude. Okay, so in that case, we can just come down here after the surface offset, hide that, and when I go about, make that mid-plane even so that's nice and careful. Up to body, up to body. There we go. Yeah. So now I can do an extruded cut as well. Make sure that we're well clear of the center there, say 300 maybe. Extruded cut. Through all both. Sounds good. Whoops. Nope, just selected bodies. Or cancel, hang on. Gotta change the feature scope there. Oh, hang on, it merged. Gotta leave this sketch and gotta come back here and say, don't merge with anyone. There we go. Is it before the merge? It made these two as into one part, but now I can hide them separately, which is what I want. So come back here, features. Nope, not whole wizard. Extruded cut. Don't auto select, just pick that one. And now we got clearance. And we'll delete these bodies because we no longer need these 2 surface bodies. Normally, if you did like a through all and then a trim using those surface bodies, you could make it consume them at the same time, but it's like this explicitly removes the surface bodies versus implicitly removing them by using intersect. So now we can convert to sheet metal, say this guy, and now all of this should be 90 degrees to one another, and everything's all flat and nice. So unhide the body over here. Now we can do the fancy stuff. So tab and slot. So let's do edge, outer surface, offset, say 50, Length 75. I want big tabs. Why is it not showing me my big tabs? I want my big tabs. Ah, I see. Might be too long. Reduce. Okay. Really? Ah, I see. Equal spacing, spacing length, 5 or something. I only really want 1, so maybe 100 millimeters long. Yeah, that looks about right. So now we can do that. Let's see, link groups together, make them all the same. To that face. Let's see. Does it tell me which one's green? Because I want the green ones to be on the same side and symmetrical so that this is the same offset in all places. It also makes the cuts on this guy symmetrical. So pseudo important, not necessarily always important, but you know, it's doing the little things and making sure that you're careful. So now, I should probably do that with some clearance. I just type just a little bit of cut on there to make things nice. Maybe 1 millimeter clearance. And then probably some chamfer corners or something just to make sure that it's, you know. Yeah, there we go. Maybe fillet corners would be better if you were worried about kerf. How long have I been going now? 40 minutes? That's not bad. But yeah, tab and slot, magic tool. One important thing to note is that you will get, let's come in with the right angle here. You will have some funkiness with your tab and slot features. Like it will be, when doing off-angle things like this. I could do it. Well, actually, it's pretty easy because these are vertical. I think the last time it was tricky because I had some issues with. I had some funkiness because I was trying to do this out of, like, these were not vertical or perpendicular to the ground, and this was also not parallel to the ground, so there was lots of interestingness. Here, the thing to note is that can I make just this body transparent? Yeah, I can. Man, that's not really clear, is it? So let's make this guy not transparent again and make this guy transparent. I think that'll show things a little clearer. Yeah, there we go. Okay, so we've got this lip that shows up because the tab and slot feature does not like working with features that are not perpendicular to one another. That's just the nature of the beast. I mean, it also does some nasty stuff, like these are not perpendicular to the top face. So when you exported that for cutting, you'd end up with like a little bit of bump out here. It's sheet metal and you're welding it, it's going to be fine. But it's just one thing to take note of because it can sometimes cause some funkiness. For the sake of being nice, we will come over here and unfix you, make you horizontal. That's probably about right. Yeah, there we go. Now we have all reasonable tab and slots, and things look nice. Yeah, I don't think I really have anything else clever to say besides that. Use tab and slots; they're great, especially if you're welding together assemblies that are like tricky to fit together. It saves your welders on fit up for it. It just makes fitting things together and requires a lot less jigging if you have tab and slot all over the place. I think I did this once with a like a 5-foot long aluminum beam that I was building that had all sorts of complicated internal webbing, and I'm told the welders hated me slightly less for using tab and slot. It made things a lot easier for them, so consider it if you're designing parts like that. It's not really useful otherwise. Maybe you could do it on 3D printing, but it just means tweaking your tolerances, so. Yeah, I hope that was helpful. I'm not really sure what else there is clever to add here. But But Rhea, if you're watching this after the fact, hey man, I hope you found something interesting in here, or like if there's something else that you'd like me to cover from the drawing you sent, or if you've got a better drawing that will let me do a couple more of the parts in more detail, that'd be awesome. I'm always happy to. Yeah, that's all I've got. Have a nice morning, midday, afternoon, evening, or night. Boink.